An applause.
Hello, everybody. I'm Matthias. I've been around GNOME for a long time. You can probably find code I've written in and around GNOME in many places. And my home base is GTK. But today I want to talk about SVG and GNOME. Or at least that's the title I put on my abstract when I submitted it. And there's certainly many things I could talk about, new places in GNOME where SVG pops up. For example, our new image loading framework in Clasen, which supports SVG, or the just merged support for SVG cursors in GNOME Shell. But really, what I want to focus on today is GTK and SVG, because that's what I spend a good amount of my time on over the past year or so. Before I dive into that, I hope you all saw Jakob's presentation a little earlier today, because he did a great job of showing you live and in action what I'm going to describe a little more chronologically and theoretical. But you'll see. Before I get to that, though, I want to give a brief background about SVG itself, although I assume that most people here know that SVG is a vector graphics format that was invented in the late 90s, back when XML was cool, so SVG is using XML. Version 1.0 of the SVG spec was finished in 2001. Version 1.1 came out in 2011. And the standardization process for SVG2 broke the monolithic SVG spec into a whole bunch of separate CSS specifications. So there's now like a CSS spec for shapes, and a CSS spec for transforms, and a CSS spec for filters, and many more. But also the SVG2 standardization process ran a little bit out of steam. There was a candidate recommendation for SVG2 in 2016, and that's one of the later stages in the W3C standardization process. But here we are more than a decade later, and there's still no final SVG2 spec. I think the web browsers have kind of lost interest in that, and the few new additions that have been added to the SVG2 drafts, new features, have been implemented only very inconsistently by web browsers, so they're now slowly getting ripped out of the spec again to finally get to the finish line, which is a bit of a sad state of affairs, I want to say. But to give you some impression of what kind of insanely broad and deep spec SVG really is, here's a graph from an SVG test suite called the RE SVG test suite, which has more than 1,600 tests, as you can see here. It has pretty good coverage of SVG, and if you look at the graph, you can see that even the web browsers, which are the primary implementers of SVG, don't even break the 90% mark on this test suite. And the test suite does not cover, for example, interactivity or animation or any of the new SVG2 additions. So there's certainly a lot to cover. And on the off chance that you've never seen how SVG looks on the inside, this is a small example. It's clearly XML, as you can see, and if you squint a bit, even though it's small, maybe you can make out that there's elements for rects and for circles and for paths. There's lots of coordinates for the path. And if you squint even more, you may be able to make out fill and stroke attributes that specify colors for these shapes. And this is how this example looks when it's rendered. Since the S in SVG stands for scalable, we can render it at any size, and it always comes out sharp. I guess so much for SVG itself. There's a lot more you could say as a vector graphics format. SVG has primitives for, as I already said, rectangles, circles, ellipses, polygons. Then there's fill and stroke attributes, and there's transforms and masks and clips and filters and gradients and patterns and text. And since it's a web invention, you use CSS to style it. There's ways to declaratively animate things. And there's event handling, so you can click on the shapes in your SVG and you can move the focus around in there. We'll get back to some of these things later on. But for now, let's switch focus a bit and talk about the GTK side. GTK has a bit of a difficult history with SVG, I want to say. For the longest time in my adult life, I've totally ignored SVG. During the GTK2 and GTK3 era, it wasn't very interesting because we needed pixels and chiral surfaces anyway. Coincidentally, that is exactly what librsvg provides. And we used it indirectly through GTK pixbuff, so we never really had to think about the SVG aspects of this whole process. And we did not have to directly link against librsvg because GTK pixbuff shielded us from that. Which was nice in a way because back when librsvg was still in C, it wasn't really a very good citizen in a G-object library world. It had its own little hand-rolled object model. And then it became an early adopter for Rust in the GNOME ecosystem. And we did not really want to deal with Rust dependencies. Recently, that has become a bit more complicated for us, even due to our Android backend. So we did not really want to link directly against librsvg. And this is, as I said, in the GTK3 days, we didn't really have any use for the scalability, the scalable aspect of SVG, but we did have a use for the CSS themable aspect of SVG, and that was symbolic icons. Jakob talked a bit about where they came from Moblin. I looked at the GTK Git history, and they appeared in GTK in 2010. At that time, the motivation was to make tray icons fit better into the top bar, which back then was GNOME panel. And from the implementation side, the way it worked is that we create a CSS style sheet, and we combine it with the SVG icon, and then we pass the combined thing to GTK pixbuff, and we get a recolored icon back. We were only replacing very few colors. There was the foreground, error, warning, and success, which is 4 colors. So a little later, Alex Larson invented a neat way to re-encode these 4 colors as channels of a PNG. So we added support for a symbolic PNG format that we could recolor without having to ever generate, parse, and render SVG at runtime. GTK was shipping a tool for doing that, for converting SVGs into symbolic PNGs. But that never really got any traction outside of GTK itself. So it was a bit of a failure. And here's how symbolic icons from that era more or less looked. As you can see, there's filled paths. The white color here is the foreground color that they are filled with. And then you can select shapes either with the arrow color red or with a success color in some green tone. And maybe there's some translucency over there. That's why that right half of the star is a little purplish. And that's where things stood with GTK and SVG when we released GTK4. And that's where they still stood in 2024 after quite a few GTK4 releases. But on the GTK side, things did actually change a little bit because with GTK4, we do have render nodes as an API, which are scalable. And early on in the GTK4 era, we added path APIs, and we also including nodes for filling and stroking paths, which in theory gives us an API that we could translate SVG to without rasterizing it first. And with the advent of fractional scaling, that became a little more important because the premature rasterization that we are forced into makes it very hard for us to take the display scale into account for finding the right resolution for rasterizing. So it's really hard to produce pixel-perfect and crisp rendering in that scenario. And I did talk to Federico, I think, at times about getting unrasterized librsvg output in some form. Ideally, we would want a render node, but any other encoding of the scene graph that we can translate into render nodes would work just as well. But Federico was totally not opposed to that, of course, but it wasn't a huge priority, and my Rust isn't good enough to try that myself. So at some point, I gave up waiting, and that was maybe the right decision because, to this day, the only output format for librsvg is still Cairo-based. But after I gave up waiting, things started moving on the GTK side. I guess we are now at the beginning of the story of GTK and SVG. In early last year, I guess in the spring of 2025, I started writing a very minimal SVG parser that was able to just about parse the amount of SVG that you could see in those simple symbolic icons that I showed a few slides ago. It was 600 lines of code, and it was good enough to render those symbolic icons. I should explain that the way I did the recoloring for this is that I just create a render node, and then I walk the render node tree and replace the colors as I go to create a new render node in the end. That works because in symbolic icons, there's no random other fixed colors that might get in the way. It's just the 4 symbolic colors, so I can just replace them as I go. Occasionally, you might see some opacity, but I managed to figure out how to make that work. And here's the commit where I pushed the very first version of this into GTK. If you read to the bottom, you can see that I was still hoping for librsvg to bail me out with a scene graph API. Oops. Oh, no, I lost my way here. So while I was working on this parser, I discovered that I can actually easily allow stroking as well, in addition to just filling, and recolor the strokes with symbolic colors as well. I guess Jakub talked a lot about new icons being stroked now. That's where this originated. To make that actually work, we needed to do a bit of work on the GSK side. We needed to make our GSK renderer cache stroked paths the same way that we already cached filled paths. And that's a bit of a recurring theme here. Whenever I added new features on the SVG side, we needed to do work on the GSK side to actually support that well. As I was doing this, I also, for the very first time, documented the format that this parser understands. So we have this documentation now. And at this point, theoretically, we might be able to live without librsvg. We have our own parser. But life isn't always kind, and it turns out that it's very easy for random SVG features to sneak into icons. And for that reason, we still need to have a fallback. If this simple-minded parser has no idea what SVG features it sees in the icon, we just have to fall back to librsvg to render it as before. So last year in June, I watched a presentation by the Apple design team about some new animation features in their SF symbols font. And I really recommend that you watch that presentation. The link is here at the bottom. It's Apple, so it's obviously very well done, and they show very polished tooling. I was intrigued and inspired by that. And I thought, this looks like things that our symbolic icons could maybe do as well. But I want to step through the 3 features that caught my eye in this presentation. The first one is simple draw in and draw out animations. If you don't know what that term means, basically you draw a path as you would with a pencil on a piece of paper. You start at one end and then you follow the path until you get to the other end, and you get a little animation that way. And the way that's typically done in SVG is that you animate the dash array and dash offset attributes. And so that's what my initial implementation of this did as well. This is how it looks. This is a screencast of the tooling I had last year around or briefly before GUADEC. And so this is probably pretty close to what I showed to Jakub and some other design team members last year in Italy. And they were intrigued by it, which encouraged me to keep going. And the next thing that caught my eye in that Apple presentation was dynamic stroke width. This is also something that Jakub had asked about. So I added an attribute to our renderer that lets us vary the stroke widths of icons, very similar to font weight would do for text. And there was one more thing that I noticed is attaching shapes to each other so that they can follow along as these draw-in animations happen. And if you look at this example here, the arrowheads are attached to the green path, so they move together with this animation. And if you actually had watched the Apple presentation, you'd have seen very polished tooling, which would have given you a nice contrast to this hacky tool that I wrote for myself. But it does the job. I wrote this tool because I knew that I needed to get Jakub to play and try out these new features. And giving him a tool to do that was the easiest solution. And if you watched this presentation, you saw him use this tool very nicely. Thanks for showing it off so I can just show a screenshot here. And to answer the question from that earlier presentation, we should figure out how to make this tool available easily. I'm a bit of two minds about it. As Jakub said, it would be great to have this as its own application that I don't have to maintain. But unfortunately, it kind of has to live inside the GTK code base because it needs to link statically against libGTK. Otherwise, I would have to make a huge amount of API public that I'm not really prepared to do. So we still have to figure out how to handle that problem. But getting back to how I actually implemented some of these things that inspired me in the Apple presentation. By this time, I had moved my parser code to an object that I called GTK pass paintable, because it implements the GTK paintable interface that we have in GTK. And so I called these animations GTK pass animations, and then I abbreviated it to GPA, which is where this acronym comes from. And so I wanted to implement these transitions that they go from somewhere to somewhere else. So in short, I needed to have some state somewhere so that GTK pass paintable object has a state property that you can set programmatically. And in the SVG content that it loads, there's this GPA states attribute that you can put on shapes to state, to declare which states they should be in or not in. And then there's these GPA transition attributes which let you specify how you want this transition to look from one state to the other for this shape. Since I wanted to keep some things pretty simple, I just implemented a fixed set of possible effects. I think Jakub in his slides had a list of these. If you want to see what's possible there, I recommend that you just figure out how to install the icon editor, even though it's not easy, and play a little bit with this yourself. And since I gave Jakub a tool, he got busy, and I think you mentioned a number like 1,100 icons. We did them all, so they are all stroke-based now instead of fill-based, and they all have dynamic stroke widths. And again, I would recommend that you follow the link at the bottom here and play with the web preview of that enormous grid of icons. It's kind of impressive, and it looks very neat. But after GUADEC last year, I realized that I had to start over, basically. So I took my parser code and put it into a new object that I called GTK SVG. And the initial focus and motivation for doing this was that I wanted to re-implement my transitions and animations on top of actual SVG animations, since the SVG spec already defines a mechanism for animating things, and I wanted my extensions to be minimal. So I did this re-implementation. It turned out that you can actually do that. But I also wanted to go for covering more of the SVG spec and add more features with this new code base. So once I started looking at various SVG test suites to see how my code is doing, I quickly decided to write a small tool that I called SVG Compare, which turned out to be very useful. It's just doing side-by-side rendering. It gives you the libRSVG rendering on the left and GTK SVG rendering in the middle, and if you have a reference PNG, it'll show that as well. And I can just point this tool at a directory full of test SVGs and scroll through and quickly see if there's any rendering differences or misrenderings that I need to fix. So that was very useful when working with test suites. But now, of course, the GTK SVG code has its own tests in the GTK repository as well. We have various kinds of tests. The parser tests they start with an SVG input and they feed it through our GTK SVG parser and then to our serializer, and we compare the end result. And then we have renderer tests, which again start with an SVG input and feed it through the parser and the renderer and produce a serialized render node as output. And we compare that to a reference. I decided to go for a serialized render node there rather than rendering to PNG, since I kind of hate hunting down single pixel differences in rendering output that come from some rounding error in some gradient implementation or something. Going to serialized render nodes, avoid that problem. And it has worked out well, I think, even though occasionally you have to just regenerate your reference output if things change. And yeah, I started looking for various SVG test suites, and I discovered this RE SVG test suite that I showed the graph of earlier. And when I first pointed my code at it and see how GTK SVG fares, I was well below 800 tests passing, so like well below 50%. But I kept chipping away at it since then, and by now all shapes are supported, and we do support transforms and masks and flips. We even have a good amount of filters supported. That required quite a bit of GSK work. We added new render node types to support the various SVG filters, and also we added few render node types that we needed to fully implement the SVG rendering model. And then eventually I also made the SVG code support CSS styling. And then even later, I figured out that I can actually also use SVG filters in our application CSS. And this is a little confusing maybe. On the previous slide, I talked about SVG using CSS, and now I'm talking about CSS using SVG. But it's different CSS, right? We have CSS that we use to style the SVG, and we have the application CSS that we use to style our application widgets. And you can use, of course, already you can use simple filters that are predefined by CSS. But here you can see somebody kindly donated this example. They're setting the backdrop filter CSS property to a URL, and inside the URL we actually define we include a whole SVG image, and that defines a complex filter that you can apply to your widget. If you do that, you get something that may look like this. So that I think is a nice feature to have. And since I'm already showing examples now, at this point I'll switch from slides to doing a quick live demo. I hope that works. It's always exciting to show a few just random representative SVGs that GTK can render now. Since this is a talk about vector graphics, I guess there has to be the Go script tiger, otherwise it wouldn't be complete. As an SVG image, this is actually pretty trivial. It's just a bunch of paths that are filled with plain colors. Maybe there's a gradient or two in there, I don't know. It's very simple SVG, but it's a classic. The next example is the Orca logo, which is a little more complex. It has actually quite a few gradients. For example, the soft shadow you can maybe make out at the bottom. That is rendered as a radial gradient with a transform to make it look like it's projected on the floor. And the next few examples come from an old SVG animation test suite that I found somewhere. This one just shows that you can move shapes around, not just on straight lines, but also on more complex paths, and you can transform them while you do that. This shows that path morphing works. This one is a little different. It doesn't animate individual shapes. It animates the viewport of the SVG instead to create this kind of flyover effect. This one comes from Wikipedia. It shows that you can actually do kind of complex animation with this machinery. It also shows that our text rendering still needs some help, but the animation at least works as intended. This one is a little different. This is from Cambalachi. Juan Pablo was an early adopter of GTK SVG, and he used the GPA states that I talked about earlier to make this little intro. So I can go down to the bottom right here now, and if I go from state 0 to state 1, something will hopefully happen. Oh yes, it does. And there's another state, state 2. More things start to show up. And then there's state 3 as well. So I thought that was a pretty neat way to make use of this capability. Right. eventually, I broke down and I even implemented interactivity. Since event handling does not really fit into a GTK paintable, I made a GTK-Svg widget, and that's just a simple wrapper around the GTK-Svg paintable, but it does the event handling. So you can now actually put links in your SVG and click on them or activate them with the keyboard. All that works. Right, the last section of my talk is usually a little bit of a look ahead. I want to talk about what you can expect coming in the next GTK release, which is going to be 4.24, coming this fall. And I want to say we'll probably have pretty comprehensive SVG support at this point. Going back to that test suite that I showed a graph of earlier, in my unscientific self-evaluation, I now come in at 1,365 tests passing. So we are kind of in the browser range now, which I think is pretty good. And there's certainly GTK-SvG covers everything that you could possibly want to use in an icon. So at this point, it's kind of hard to justify chasing more coverage in this test suite, but there's still like one or two easy things that I might try to improve here anyway. But beyond that, there's still more work we could do, for example, to implement more filters. That does need more GSK work, though. Every time we implement a new filter, we need to make sure that we have a shader that can match that implemented on the GPU. The candidates for that would be, for example, convolution or morphology. And it would also be nice to have a better blur implementation in GSK, for example, that could let us specify the X and Y radios separately. And beyond that, there's integration things that we could try to improve, like some plumbing. The SVG CSS implementation uses the same CSS parser that GTK itself uses as well, but the CSS engines are separate. It would be nice to unify that and make the SVG code use the GTK CSS engine, but that is a lot of very tricky work that I've kind of shied away from so far. It would be nice because it would make the SVG implementation more scalable, probably. Currently, the SVG CSS implementation doesn't do any change tracking. The moment anything changes, we just recompute everything, which works fine for simple icons. It starts to become a problem if you make a very complex, big SVG with lots of moving parts, like maybe the Campbellacci intro that I showed is a bit borderline. We made some test SVGs that have like 10,000s of shapes, and if you start animating one of them, everything slows to a crawl. So that is maybe something to look into at some point, but I'm not volunteering yet. And with that, I'm at the end of my prepared material. As always, my slides are available on GitLab, and these are the URLs for the other things that I mentioned in my slides. And with that, I ask if there's any questions.
Thank you, Matthias. If we have any questions from the public, please raise your hands. In the meantime, people that are watching from home, if you have questions, please send them in the chats in Matrix or Telegram.
Hi. As an app developer, I'm quite interested in like all the new animation stuff that'll be possible with GTK's new SVG renderer. I'm just wondering like how I would go about doing that as an app developer and how difficult that would be, if that makes any sense.
So my work on SVG started because I wanted to improve our icon rendering, so I treated it as like an icon image format essentially. So the implementation is currently kind of separate, like you make a GTK SVG widget, and then that's one widget inside your overall application. So it's not quite integrated in the same way that the browsers have done it. Like in HTML, you can just randomly put an SVG element here or there, and it's just part of the overall thing. So it's a little more isolated, I would say, in our current implementation. So you have the SVG part, and then you have your widgets, and they don't necessarily interact much with each other. There would be some ways to think about maybe using that foreign object element that SVG provides. You could use that and maybe map the foreign objects in your SVG to widgets and have them become part of the SVG scene graph that way. I've thought about that, but I haven't really done experiments to see how interesting that would be. So from that perspective, the integration isn't quite there yet, but there's certainly potential to play around with that and see where it goes.
Cool. Thank you.
Any other questions? Okay, thank you, Matthias.